All right, welcome. This is 7.2, which is graphing rational functions. The super awesome thing about this section is that you get a graphing calculator, and it does a lot of the work for you. Okay, so I've got three examples here. The first two are just graphing and talking about how to graph from two different forms, and then the second one is where I give you one of the forms and you have to go to the next one. So on A here, this is what I called vertex form. Again, that's not what it's actually called, but that's what I call it. And we want to find the domain, the range, the horizontal asymptote, and the vertical asymptote. Okay, so when you're looking at something like this, you could graph it in your graphing calculator. There's no reason why you couldn't, but I'm not going to just because I have all my information without graphing it. So here, you find your domain when you look at the denominator and figure out, okay, well, what can x not be? And that denominator can never be 0, so that means that x can never be 1. Okay, and if you remember, the domain and the vertical asymptote are always paired together. So if the domain, really we should have all real numbers, x cannot be 1, then our vertical asymptote happens at the number x equals 1. Okay, that's a line. And then our range, our horizontal asymptote happened at y was equal to k. If you remember, our asymptotes were found at x equals h and y equals k, so that means that our horizontal asymptote is found at y equals k. And our k value here, is 3, okay? And then that means that our range is all real numbers, but y cannot be equal to 3 because that's our asymptote. That's the line that our graph approaches but never touches, okay? So that's where we're going to be. On B, this is what I called standard form. Again, not what it's actually called, but what I call it, okay? And this looks a little different, and we find our asymptotes a little bit differently, okay? We still have our domain, our range, our horizontal asymptote, and our vertical asymptote. We find our vertical asymptote the same way by setting the denominator equal to 0. The value that makes that 0 is -2, so our vertical asymptote happens at the line x equals -2. So that means we can restrict our domain to all real numbers, but x cannot be -2. You find the horizontal asymptote a little bit differently though. Okay, that's when you take the coefficients of your x's and you divide them. So the horizontal asymptote is found at the value 3 over 1 or just 3. So then you can restrict your range to be all real numbers, but y cannot be +3. Okay. It's just a lot of stuff you got to memorize. You can also look at your graph. I'm cool with that as well. You do whatever it takes to get the right answer besides cheating, because that's bad. Don't do that. All right, this last one here. It says rewrite g of x is equal to 2x plus 5 over x plus 2 in the form g of x equals a over x minus h plus k. And this was one of those things where you just got to do it, and you shouldn't have known how to do it to begin with, and you're just going to take my word for it, and it actually ends up working out, and you guys all thought it was super cool. So anyway, here we go. We're going to use long division, so we're going to take 2x plus 5, and we're going to divide it by x plus 2. Okay, x goes into 2x 2 times. Then we subtract 2x plus 4. And when we subtract, the 2x goes away. 5 minus 4 is +1. So we are left with a 2 plus 1 over what we were originally dividing by, which is x plus 2. And if you can't see it yet, I'm going to switch that around so it looks like that. And that, my dear friends, is exactly what they want us to do. Okay, so don't think too much. I know you're as amazed as I am on how that worked, but anyway. Okay. Yeah, hopefully that helps. If not, come see me and we can get you a little bit more assistance. Thanks for watching.